Hey peeps, it's Jedd here from Disrupt Tutoring, and as always, it's such a pleasure to join you. Today we're going to deal with an exponential function, and with that in mind, let's dive straight in. They've given us this curve h of x equals 4 times 2 to the minus x plus 1. They've then said to us, determine the coordinates of the y-intercept of h. Okay, so let's do that first. So in order to calculate the y-intercept, we always need to let x equal 0. So we're going to plug in a 0. So that is going to be h of 0, which is equal to our y, which is equal to 4 times 2 to the minus 0 plus 1. That 2 to the minus 0 becomes 1, because remember, anything to the 0 is 1, plus 1, and that gives us 5. So therefore, our y-intercept in this case is going to be the point 0 and 5. I'm going to erase this to give myself some space for the next question. In the next question, they've asked us, explain why h does not have an x-intercept. Alright, so in doing this, let's try and find the x-intercept and see if we can figure out why we can't get an answer. Okay, so in order to find our x-intercept, let y equal 0. Okay, so we're going to have 0 is equal to 4 times 2 to the minus x plus 1. Right, let's move that 1 across. 4 times 2 to the minus x. Let's get rid of that 4. So we're going to have minus 1 over 4 equals 2 to the minus x. Now let's convert that into something that looks like the right-hand side. All right, and let's move that. Let's move the 2 to the top, which will give us a negative exponent. Alright, so as you can see, no matter what we do here, we can never get the two bases to look the same. What I also want you to notice is, do you see how this is 2 to the minus x? Now let's plug in any number here. So if x is 1, that would be 2 to the minus 1, which would be a half. Because remember, when you have a negative exponent, all it means is that you should, in order to make that exponent positive, move the numerator to the denominator, and that would make it positive. But what that does not do is transform the number into a negative. So this side can only always be positive, whereas this side can only always be negative, and therefore there is no solution. Okay, so there is no solution for that, and that is why you cannot get an x-intercept in this particular case. Moving on to our next question. They've asked us to draw a sketch of graph H, clearly showing all asymptotes, intercepts, with the axes and at least one other point. Alright, so let's get on to that one. Okay, so one thing we haven't got, so we've got our y-intercept, we also know there isn't an x-intercept. One thing we do need to figure out is our asymptote. So let's find them. So our asymptote, and the asymptote we can take directly from the formula that they've given us. Right, this curve has been shifted up by 1. We know the typical exponential graph has an asymptote of 0. Because this graph is shifted up by 1, our new asymptote is going to be the line y equals 1. All right. And then we need to find one other point. So what I suggest is let's just plug in an x equals 1. Okay, so let's subs in x equals 1 into our h of x. So let's do that. H of 1 is equal to 4 times 2 to the minus 1 plus 1. That is going to give us 4 times 1 over 2 plus 1, which is going to give us 2 plus 1, which is going to give us 3. So that means we have another point, and I'm going to call that point A, and that point is going to be the point 1 and 3. Now we've got enough information to draw the curve. I'm going to change my pen color so that you can see it clearly. So the first thing I'm going to do is I'm going to draw in my asymptote, which is going to sit on the line y equals 1. Okay, and I'm going to mark that down. That is the line y equals 1. Perfect. Then we need to mark in our point. So we've got a y-intercept of 0, 5. So that is that point over there. So that's our y-intercept. And then we've got the point A, 1 and 3. So that's going to be this point over there. Okay. Right, so now we're going to connect those 2 points, and it needs to look like an exponential function. So it's going to look like something like this. I'm going to try again. Try and connect those 2 points. Oh, that looks a bit better. remember to put some arrows on the end. So we put some arrows on the end, and then we have to mention that this is our h of x curve. We should also mention what these points are. So at the y-intercept, I'm going to say this is the point 0 and 5. And at my point A, I'm going to mention that that point is 1 and 3. And if you do that, you'll get some marks for the shape, you'll get some marks for the additional point, a mark for the y asymptote. So in general, some good marks here, but well-deserved marks as well. Right, so let's move on to our very last question for this section. Hopefully you have a much better understanding of exponential functions now. All right, so I'm going to change my pen back. So in 5.2.4, they've asked us to describe the transformation from h to g if g of x equals 4, 2 minus x plus 2. So let's look at what gx is. So we've got g of x is equal to 4 times 2 to the minus x plus 2. If we times the 4 in, we'll have 4 times 2 to the minus x plus 8. Okay, so now let's compare g of x to h of x. We can see that h of x, all right, we can see that h of x, the difference here is that we've got a plus 1 in h of x and we've got a plus 8. What does that mean? It means that this curve that we've drawn, if it was g of x, it would shift upwards by 7 units. So therefore, to move from h of x to g of x, okay, that is an upward shift or a vertically upward shift of 7 units. Okay, so we've gone from moving h of x up by 1, here we're moving it up to 8, so the difference there is 7 units. So that's why it's a vertically upward shift of 7 units. Thank you so much to our sponsor for making this video possible. I really hope it helps you understand exponential functions a little bit better. Remember to read all about them in the description below. Also, head over to our website for more of these epic tutorial videos. If you can't find the answer to your question, send us the question and we'll respond with a personalized video just for you. Until the next time, stay epic.